Today we're going to be doing section 9.7, which is going to be mixing derivative rules. So what happens when you have to do more than one derivative rule at a time? Now, at the very top, what I've done is that I've pulled some examples straight from the book and just put them here so that you can reference them. So let's go ahead and get started. If we look at this one and we're asked to find the derivative, and by the way, we don't have to simplify this, we're going to have 7/3 x to the fifth times 4x to the third minus 7, all of that to the fourth. So what we want to do is we want to kind of group this together by pieces. So what I notice is that I have this piece times this piece. So what I need to do is that I'm going to have to use the product rule, and this is going to be my f, and this is going to be my g. So the product rule says that I'm going to have y prime equals the derivative of f, which that 5 is going to come down in front, and that'll be 35/3 times x to the fourth, times, and then you leave g alone, so that would be 4x to the third minus 7 to the fourth, plus, now we're going to leave f alone, so leave that as 7/3 x to the fifth, times the derivative of g. Well, when I take the derivative of g, I'm actually going to have to use one more derivative rule, which is going to be the power rule, okay, because I have that whole thing to the fourth. So remember, we take the derivative of the outside, so we bring that exponent down in front, leave the inside alone, subtract 1 from the exponent, times the derivative of the inside. So that would be 12x squared. Remember, the derivative of 7 is 0, so we'll be left with that. Great, and then we would typically simplify it, but I'm fine if you leave it like this. Now on that next one, we have x squared plus 2 to the third divided by x to the fifth plus 7. So again, I'm going to break this up into chunks. So what I see is that I see that I have this whole top part being divided by this whole bottom part. So when I do this, I'm going to be using the quotient rule. So this is going to be my f, and this is going to be my g. So y prime then, using the quotient rule, is going to be the bottom times the derivative of the top. Now when I take the derivative of the top, I'm going to have to use the power rule. So that's going to be 3 times, leave the inside alone, times the derivative of the inside, minus, so the bottom times the derivative of the top, minus the top times the derivative of the bottom, which is going to be 5x to the fourth. Remember, the derivative of a constant is just 0. All divided by the bottom squared. So again, what we had to do is that we had to mix two different rules. So we had to mix the power rule with the quotient rule. Now on the next one, what I see is that I'm going to have two different rules. But first off, the first rule I see is that I have all of this stuff raised to the fifth power, and then when I look on the inside, I'm going to have to use the product rule because I'm multiplying those two guys together. So when I take the derivative of y prime, first I'm going to have to use a power rule for the outside, so it'll be 5 times, leave the inside alone, times the derivative of the inside. So when I take the derivative of this inside chunk, I'm going to have to use the product rule. So that'll be the derivative of the first one times the second one left alone, plus the first one left alone, times the derivative of the second one, which is 1/2 x to the negative 1/2, plus 3. And again, I am super happy if you guys leave it like that for an exam. Now this next one is going to be very similar because we have the big thing on the outside is that we're raising it to the 13th. And then on the inside now, these two pieces are actually dividing, so we're going to have to use the quotient rule. So when we find y prime, first we're going to take care of that big outside piece, so that'd be 13 times, remember, leave the inside alone every time you do the power rule, leave that inside alone, times the derivative of the inside, so that's the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Great, so really the hardest part is figuring out which one do you do first. Okay, so it's not a bad idea to see how they're clumped together, how would the order of operations tell you to tackle this, and then go from there. Alright, these next two are going to be mixing a couple more rules together. So first off, I notice that I have a top and I have a bottom. So I'm going to have to use the quotient rule on this guy. So y prime is going to be the bottom times the derivative of the top. Now when I take the derivative of the top, I can rewrite that top piece as 2x minus 1 to the 1/3. So when I take the derivative of the top, I'm going to have to use the power rule. So that will be 1/3, leave the inside alone, raised to the negative 2/3, remember because we have to subtract 1 from the exponent, times 2, so we have the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. So again, we started out using the quotient rule, but inside the quotient rule, we had to use that power rule. Alright, the very last one, f, what we can see here is that we have x to the third times the square root of 4x cubed plus 1. So again, because these two are multiplying, and that's the big outer operation of these two pieces, we're going to have to use a product rule. So that will be 3x squared, so the derivative of the first one, times, remember, leave that second one alone, plus, now we're going to leave the first one alone and multiply by the derivative of the second. The key here is that you can rewrite that as 4x to the third plus 1. And remember, taking the square root of something is the same as raising it to the 1/2 power. So that would be 1/2, leave the inside alone, 4x cubed plus 1. Don't forget to subtract 1 from the exponent, so it would be to the negative 1/2, times, that's going to be a 12x squared. Don't forget the derivative of 1 is just 0. And again, I'm totally cool if you want to leave your answer like that, that's great. Neat, so we looked at mixing derivative rules. Remember, the big thing is trying to break it down into one rule at a time. So here we did the product rule, here we did the quotient rule, and then above that we broke it down into the power rule first, and then following through and seeing what is the next rule you have to use. So here we had to use power rule first, and then the quotient rule. Here we had to use the quotient rule first, and then the power rule. And here the product rule, and then the power rule, aka use substitution. Or it's not use substitution, I'm sorry, it's also known as the chain rule. So remember, it's nice to have a little highlighter with you, or print out your homework and take a look at it like that.